Hi students, welcome to this course, PLC Automation, an introduction to programmable logic controller. I am Professor Yao. PLC sequencer function. Objectives. The keywords: drum switch, PLC ladder program, PLC sequencers program, PLC sequencer function, a timing sequence, cascade and chain sequencers. Objective: at the end of this chapter, you will be able to compare the operation of a conventional drum switch with a PLC ladder program and a PLC sequencer program. Describe the basic PLC sequencer function. Apply the PLC sequencer function to an operational program. Apply timing sequence to a PLC sequencer operation. Describe the major PLC sequencer function and their application. Show how to cascade and chain sequencers. Introduction. The keywords: the drum controller function, table to register, file to word, cascading, chaining. The PLC sequencer function is often called the drum controller function. We use the function designation DR instead of SQ, which has already been designated for square root. The sequencer concept has evolved from the mechanical drum switch, which is an important control device, but the PLC sequencer function handles large sequencing control problems more easily than does the drum switch. This chapter explains how the PLC sequencer function operates and can be applied to control programs. Some PLC use the table to register or file to word function as an alternative to the sequencer function. In some applications, you need additional size programs to accommodate large machines and long programs. This increased size is accomplished by cascading, sometimes designated as chaining, which is covered in the last part of the chapter. Electromechanical sequencing. Electromechanical drum controller. A 3-position 6 electrical terminal devices. Motor reversing application. The armature disc. The alternating current, AC. Direct current, DC. Toggle switch. Electric mechanical sequencing. Figure 19.1 shows a small electromechanical drum controller. It is a 3-position 6 electrical terminals devices. For motor reversing application are illustrated in figure 19.3. This picture shows electromechanical drum switch. This picture shows internal contact switching for figure 19.1. This figure shows motor reversing applications. Motor reversing is accomplished by reversing any 2 leads for 3-phase alternating current AC, reversing the start lead with respect to the main lead for single-phase AC, or reversing the field leads with respect to the armature leads for direct current DC. Drum switches are limited to a maximum of 7 positions and about 16 pairs of contacts. The switches cannot handle a process within 27 devices and 138 steps. For example, unlike the PLC sequencer's function, which can easily handle the 27 by 138 control or more. A simple sequence of operation is shown in figure 19.4. 3 lights are to be in the on or off state in 5 consecutive different combinations. The 5 steps are to be in a given sequence, 1 through 5. A 1 indicates the light is to be on and a 0 off. The required light pattern sequence of figure 19.4 can be accomplished by manually opening and closing 3 toggle switches, as shown in figure 19.5. This picture shows light pattern sequence of light control. This figure shows toggle switch light patterns control. Figure 19.5 shows the open or closed status of the 3 toggle switches for each of the 5 required sequential patterns. As an alternative to using toggle switches, the 3 lights could be connected to the output of a PLC using the coil contact system, as shown in figure 19.6. This picture shows PLC coil contact light pattern control. Input could be programmed as shown with 5 input switches, 1 for each pattern. Closing input 001 would result in sequence pattern 1, input number 2, pattern 2, and so on, up through input 5, resulting in pattern 5. Homework: handwriting of keywords and submitting them to course Facebook. Just do the online quiz, and see you next time.